Fracking. Fracking, also known as hydraulic fracturing, hydrofracturing, or hydrofracking, is a well stimulation technique involving the fracturing of bedrock formations by a pressurized liquid. The process involves the high-pressure injection of fracking fluid, primarily water, containing sand or other proppants suspended with the aid of thickening agents, into a wellbore to create cracks in the deep rock formations through which natural gas, petroleum, and brine will flow more freely. When the hydraulic pressure is removed from the well, small grains of hydraulic fracturing proppants, either sand or aluminium oxide, hold the fractures open. Hydraulic fracturing began as an experiment in 1947, and the first commercially successful application followed in 1950. As of 2012, 2.5 million frac jobs had been performed worldwide on oil and gas wells, over 1 million of those within the US. 4. Such treatment is generally necessary to achieve adequate flow rates in shale gas, tight oil, and coal seam gas wells. 5. Some hydraulic fractures can form naturally in certain veins or dikes. 6. Drilling and hydraulic fracturing have made the United States a major crude oil exporter as of 2019. 7. But leakage of methane, a powerful greenhouse gas, has dramatically increased. 8. 9. Increased oil and gas production from the decade-long fracking boom has led to lower prices for consumers, with near-record lows of the share of household income going to energy expenditures. Hydraulic fracturing is highly controversial. 12. Its proponents advocate the economic benefits of more extensively accessible hydrocarbons. 13. 14. As well as replacing coal with natural gas, which burns more cleanly and emits less carbon dioxide, CO2. 15. 16. And energy independence. 17. Opponents of fracking argue that these are outweighed by the environmental impacts, which include groundwater and surface water contamination. 18. Noise and air pollution, and the triggering of earthquakes, along with the resulting hazards to public health and the environment. 19. 20. Research has found adverse health effects in populations living near hydraulic fracturing sites. 21. 22. Including confirmation of chemical, physical, and psychosocial hazards such as pregnancy and birth outcomes, migraine headaches, chronic rhinosinusitis, severe fatigue, asthma exacerbations and psychological stress. 23. Adherence to regulation and safety procedures are required to avoid further negative impacts. There is considerable uncertainty about the scale of methane leakage associated with hydraulic fracturing, and even some evidence that leakage may cancel out the greenhouse gas emissions benefits of natural gas relative to other fossil fuels. For example, a report by Environmental Defense Fund, EDF, highlights this issue, focusing on the leakage rate in Pennsylvania during extensive testing and analysis was found to be approximately 10%, or over 5 times the reported figures. 25. This leakage rate is considered representative of the hydraulic fracturing industry in the US generally. EDF has recently announced a satellite mission to further locate and measure methane emissions. Increases in seismic activity following hydraulic fracturing along dormant or previously unknown faults are sometimes caused by the deep injection disposal of hydraulic fracturing flowback, a byproduct of hydraulically fractured wells. 27. And produced formation brine, a byproduct of both fractured and non-fractured oil and gas wells. 28. For these reasons, hydraulic fracturing is under international scrutiny, restricted in some countries, and banned altogether in others. 29, 30, 31. The European Union is drafting regulations that would permit the controlled application of hydraulic fracturing. Mechanics. Fracturing rocks at great depth frequently becomes suppressed by pressure due to the weight of the overlying rock strata and the cementation of the formation. This suppression process is particularly significant in tensile, mode 1, fractures which require the walls of the fracture to move against this pressure. Fracturing occurs when effective stress is overcome by the pressure of fluids within the rock. The minimum principal stress becomes tensile and exceeds the tensile strength of the material. 33, 34. Fractures formed in this way are generally oriented in a plane perpendicular to the minimum principal stress, and for this reason, hydraulic fractures in well bores can be used to determine the orientation of stresses. 35. In natural examples, such as dikes or vein-filled fractures, the orientations can be used to infer past states of stress. Veins. Most mineral vein systems are a result of repeated natural fracturing during periods of relatively high pore fluid pressure. The effect of high pore fluid pressure on the formation process of mineral vein systems is particularly evident in crack seal veins, where the vein material is part of a series of discrete fracturing events, and extra vein material is deposited on each occasion. 37. One example of long-term repeated natural fracturing is in the effects of seismic activity. Stress levels rise and fall episodically, and earthquakes can cause large volumes of connate water to be expelled from fluid-filled fractures. This process is referred to as seismic pumping. Dikes. Minor intrusions in the upper part of the crust, such as dikes, propagate in the form of fluid-filled cracks. In such cases, the fluid is magma. In sedimentary rocks with a significant water content, fluid at fracture tip will be steam. Make sure to like and subscribe to the channel, and tune in for part 2 of this video, where we will go over the history of fracking.